In today's class, we will discuss convolutional code, how it works and how it is different from other block codes. So till now, the block codes which we have studied are one-dimensional codes, whereas convolutional code is a two-dimensional code. One more difference between the block code and the convolutional code is that suppose you have a 4-bit data, you will be getting a 7-bit code for the other methods. If you have a 3-bit data, you will be getting a 6-bit code for the other block codes. Whereas convolutional code differs in this manner. It is a two-dimensional code and you can change the number of bits as per the circuit used. So how convolutional code works, that first we will see. It is a combination of shift register and a logic circuit. This is a shift register concept. We are using 3 flip-flops, M1, M2 and M3. Let us take any input bit stream. Input bits, it can be of any bit. Like suppose you are taking 1101 is the input data. So initially these flip-flops are set at 100. You can say this is set. Then the most significant bit will enter in the first flip-flop. The bit stored in the first flip-flop moves to the second flip-flop, and this bit moves to the second flip-flop. Then this bit will come here, this will shift to this bit will be shifting to this. Sorry, this will be 0, and then this is 1, this is 0, this is 1, then this 1 is here, this 1 will come here, this 0 will come here. Now all the bits are entered in the first flip-flop, it will be now set to 0. This 1 will come here, this 1 will come here, this will remain 0, this will be 0, this is 1, this is 0, this is 0 and this is 0. So again it has become 0, 0, 0. This is your reset. So first it was set at 0, 0, 0. Second it is resetting again at 0, 0, 0. 1, 2, 3, 4, 5, 6 and 7. Seventh step it is resetting. But there is a condition which is known as resetting condition. Now what is that resetting condition? It is the number of flip-flops plus length of input. How many flip-flops we have used? 3. And what is the length of our input data? 4-bit. So total 7. So this is the resetting condition. It is always there. That means the number of flip-flops and the number of input bits you have to add, and then that number is the resetting condition. Sometime what happens then, instead of 1101 there may be some other types of input like 0111. So maybe in 0111 your resetting condition comes at either at the 5th position or at the 6th position. But even then we need to write 000000 how many times? Till the 7 steps completes. That is, it should come to the resetting condition. So this is how you first of all make this shift register concept, and then the convolution code comes into picture. Suppose this is your shift register, this is your input, these are the outputs. Now these outputs basically needs to connect in a logic. Like for example, I have connected these two output together and get the output V1, and S2 and S3 connected with an XOR gate and the output is V1. So what will be the V1 bit? S1 XOR S2, and what will be the output V2? It is S2 XOR S3. So this way you will get 2 different bits for operation. How many bits you will get? 7 bits for V1 and 7 bits for V2. Overall 14 bits you will get. So that means for a 4-bit input, you will get a 14-bit output or the 14-bit code as a convolutional code. But as I told you, you can change the number of bits in the output by changing the logic. Like for example, in this case, I have taken V3 like this. So V3 will be what? V3 is nothing but S1. So now 7 bits here, and 7 bits for V3. So 7 plus 7 plus 7, 21 bits. So same input 4 bits, but you will get the output as 21 bits. So this is how you can change the output of convolutional code as per your requirement or as per the circuit or the combinational logic used. Let us take an example to understand the convolutional code better. So such type of question will be asked in the exam. Something like this, a diagram will be given to you in the exam and they will say find the convolutional code for the following figure. So from the figure what we can see that the input bit is 1100, 4-bit input. There are 3 flip-flops we are using and the output or the codes you are getting by this connections. So what will be the output? Output bit V1 is nothing but S1. Output bit V2 is nothing but S1 XOR S2, and output bit V3 is nothing but S1 XOR S2 XOR S3. So this way 7, 7 and 7, 21 bits output will be there for the input data 1100. Now let us start the operation. Initially the set condition is 0, 0, 0. Then this 0 will come to this place, this 0 will shift here, this 0 will shift here, then next 0, this 0 will come here, this 0 will come here, then 1, 0, 0, then finally 1, 1, 0, it will become 0, 1, 1, 0, 0, 1, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. So as you can see at the 7th stage it is reset. So you need not to take this set condition. After this set condition you have to take all the values for the operation. So what will be the code V1? V1 is nothing but S1. S1 is this column, that is 0, 0, 1, 1, 0, 0, 0. So V1 I have written the first column as it is because V1 is nothing but S1. So the same bits I have written here. Then I will take V2. V2 is S1 XOR S2. 0 XOR 0 is 0. 0 XOR 0 is 0. 1 XOR 0 is 1. 1 XOR 1 is 0. 0 XOR 1 is 1. 0 XOR 0 is 0 and 0 XOR 0 is 0. You know XORing, when you XOR two same bits the output is 0, and when you XOR two different bits the output is 1. So only at this point bits are different, one is 1, one is 0. So it is 1 and then it is 0, it is 1, again here it is 1, rest are the 0. Then finally V3. So in V3 we have to XOR all the 3 bits. So 0 XOR 0 XOR 0 will be 0. 0 XOR 0 XOR 0 will be 0. 1 XOR 0 XOR 0 will be 1. 1 XOR 1 XOR 0 will be 0. 0 XOR 1 XOR 1 will be 0. 0 XOR 0 XOR 1 is 1 and 000 will be 0. So these 21 bits are known as the convolutional code for the data 1100. This is how you can calculate the convolution code for the data bit given. Now this data bit can be different, the operation can be same. So for different data bits you can get different 21 bits convolutional code. But another thing is you can keep the data bit same and you can change the connections. So for the same bit you can get different convolutional code. So this is how you can understand the concept of convolutional code. I hope it is understood. If any doubt, if any query, you can write it in the comment section.